Hello everyone, my name is Sawa Bakr. I'm going to demonstrate today the Personal Research Assistant. The main purpose of this project is to have an agent or an application that allows users to search documents that are saved in large storages and also to utilize web search for latest information. And if the user wants to upload documents on the spot, they can upload it, and then it will research data from all or search data from all of those three types and return responses to the user. It uses semantic search to provide grounded answers with references and downloadable sources. The problem statement is users struggle to efficiently search and retrieve information from large collections of documents. Traditional keyword search lacks semantic understanding, and there is a need for system that combines document retrieval with modern LLM reasoning. The researchers and companies would benefit from locating their files in a place that is accessible by LLM that easily responds to any inquiry. The project objective is to build a RAG-based research assistant that supports document uploads and persistent storage. Whenever I say persistent, I mean data that is saved ahead of time in a location, and it might be a large amount of documents, PDF or text documents, and it will be utilized through the application. It also provides semantic search with source references, and it combines internal document retrieval with web search. What is RAG? RAG combines information retrieval with large language models. Relevant document chunks from, basically relevant documents are broken into chunks and are retrieved before generating responses. And the most relevant document will be returned. This improves factual grounding and reduces hallucination. The technologies used is Streamlit for web interface, Llama index for indexing and orchestration, and this library was used heavily. ChromeDB as a vector database, OpenAI GPT-4o Mini, and OpenAI embeddings, hybrid retrieval and re-ranking pipeline. This screen shows the application architecture. Here the user pushes his question through the Stream UI to the OpenAI. So he basically asks the question, and then the OpenAI agent will utilize both the RAG pipeline and the web search to retrieve the answer. So when it comes to the RAG pipeline, the RAG, whether it's the persistent database or the uploaded documents, it will be broken into chunks and then pushed further. And when it comes to the web search, the OpenAI will retrieve the most relevant response and generate links from the internet and then push it to the next step. And next, there's the reciprocal re-ranking that is used to capture the most relevant responses and generate the responses and push it to the next layer, which is the LLM re-rank. LLM re-rank refines the answers and returns only the most relevant responses to the question. And finally, those responses with the resources are pushed to the user using the interface. The application flow starts with the document ingestion from the sources that are saved ahead of time, and then it's chunked into several chunks, and then these chunks will be embedded, used to generate the embeddings, and the embeddings will be saved in a vector database, which is the ChromaDB. And then the user asks the question, It's the relevant chunks or relevant vector indexes are captured from the database, and using the retrieval methods that we discussed earlier, it will be re-ranked, and the relevant response will be returned to the user after massaging it, or after the LLM modifies it to a more reasonable response, and it will return with the resources. Vector storage and embedding is utilized for documents that are converted into embeddings using the OpenAI embedding models. Embeddings are stored in ChromaDB for semantic similarity search, and persistent storage prevents redundant embedding generation. For hybrid retrieval pipeline, we have the system that combines internal RAG retrieval with web search. Query fusion merges results from multiple retrievers, and LLM re-ranking is used to improve relevance of the responses and remove noisy results. For conversational agent, we have an OpenAI agent that routes the queries between document search and web search using a tools feature. And chat memory is used to preserve context across interactions. And streaming is utilized for responses to improve user experience. When it comes to the system features, we have upload private documents and persistent vector database, which is the large database saved ahead of time. Semantic search that is utilized to improve the response return to user. Web search integration is done to retrieve the most relevant responses, and source transparency is captured by providing the user with links and downloadable interface and downloadable references. What are the advantages of the solution? Improved factual grounding using retrieved context. It also supports both local documents and live web information. It provides transparent citation and references, and it's a scalable architecture for future extension. Limitations is it's dependent on embedding quality and retrieval accuracy. Large datasets increase storage and retrieval costs, and web search quality depends on external sources. LLMs may still occasionally hallucinate in the solution. The main challenges that were faced is API cost management, reducing the embedding to reduce the embedding cost. What I've done is using smaller datasets during the development. And the other challenge is the dependency challenges. So basically, while preparing the libraries and the imports, there were so many dependencies due to the some depreciated libraries. So that was a bit of a struggle. Retrieval accuracy is basically to improve the retrieval accuracy. I had to explore features like query fusion, retrieval, and LLM re-ranking, especially that there are 3 types of resources, as we mentioned earlier. So this helped in returning the best resource based on the inquiry provided by the user. The next challenge is the storage optimization. What I've used is persistent vector storage to avoid rebuilding embedding repeatedly. Web search integration, combining web search with document retrieval to improve answers and maintain reliable resources was one of the challenges which I provided basically the web search to improve the results, especially when it comes to questions that are out of the document. Because what I've noticed is that the responses, when it's not in the document, is basically based on the knowledge that the models have. So adding the web search improved the results that were returned to users. Future improvement is adding multimodal retrieval support, deploying advanced scalable cloud infrastructures for large amount of data, improving ranking using advanced re-rankers, and adding authentication and multi-user support. And as a conclusion, the project demonstrates a functional RAG-based personal research assistant. The system combines semantic retrieval with re-ranking and web search to improve the results returned to users. It provides grounded answers with transparent references. There is a lot of room for improvement in future. I'll just go briefly through the demo. So here, as you can see, this is how the search application or the agent would look like. On the left, you'll notice there is an upload feature for instant documents to be uploaded. And just beneath that, there's a clear uploads and history. So this would clear the full history of the chat, and it will clear the uploaded document indexes. And in the middle, we can see the chat box where the user can ask a question, which would be shown in red as shown here at the top, and then the responses would appear below. And then, as you can see in the second screenshot, the links for the references appears too. Those screenshots here show the first screenshot is basically showing a general question, which returns links from websites. Now, this screenshot shows question that is capturing data from data in the database, in the long-term database, basically. So this question returns the details of a shipment or an order. And on the right, we can see the second screenshot, which represents the reference, which is the downloadable order. And the last screenshot at the bottom shows the a follow-up question, which basically is a follow-up question to the order itself, and it represents the memory. It shows that the memory is actually working here of the chat. This screen here shows the order that is a question against an order document that is uploaded on the spot, and it also shows in the second screenshot below the downloadable document as a reference. Thank you, and thanks. Have a nice day.